Okay, so we got very similar problem, so I'll just do it a second time. 16 cosine squared minus 16 cosine x equals negative 3. This is a quadratic. It just has trig functions in it, like the one we just did. And so I'm going to add 3 to both sides so I can set this up with everything on one side and 0 on the other so that I can factor this left side and get independent factors. 16, I can't divide anything by 3. Can't divide anything by 16 without getting a ratio. So it's probably easier if I just take 16 times 3, which is 48, and then find factored pairs of 48. I just write it this way. That line doesn't mean anything. And so since I don't know off the top of my head, I'm looking for factored pairs that add up to negative 16. So I go, I definitely know it's not going to be 1, nor is it going to be 2. So I'm going to try 3. Negative 3 times negative 16. That's not going to work. And so 3 and 16 is not. And so I know that negative 3, negative 16 is not going to work. So let's try negative 4. And yep, I get it to work. So we got negative 4 times negative 12 is equal to positive 48, but negative 4 minus 12 is equal to negative 16. So again, remember this informs us how to split our middle term. So I get 16 cosine squared x minus 4 cosine x minus 12 cosine x plus 3 is equal to 0. And I'm going to group these two together, and I'm going to group these two together. I'm going to factor from this guy a 4 cosine x, and what I'm left with is 4 cosine x minus 1. And this one, I'm going to factor out a negative 3. And what I'm left with after I factor out a negative 3 is 4 cosine x minus 1. And all of that stuff is equal to 0. And with that being equal to 0, I can now factor this and this away from that part. 4 cosine x minus 1. And I'm left with 4 cosine x minus 3. And that's all equal to 0. Now that they're independent factors, I can consider them as separate and figure out when this blue one is going to be equal to 0, independently of when the orange one will be equal to 0. So add 3 to both sides. Divide both sides by 4. And that is not going to be one of our nice angles. So I'm going to have to take the inverse cosine of both sides and get some ugly number. What did I do there beforehand? Back to where mine took us. So you're going to have to do some inverse cosine. I don't have a calculator in front of me, so we're going to have to do that separately. Or I can insert it in here. Oh, maybe I can do it intelligently here. So inverse cosine. Inverse cosine of 3/4. Inverse cosine of 3/4. I really want to be in degree mode, I think, for this. I don't know. I guess it doesn't matter. I don't think it matters. So 0.7227. 0.7227 radians. So x equals 0.7227 radians. And then if I look at this orange side, equals 0. Add 1 to both sides and divide both sides by 4. So I get 1/4. I take the inverse cosine of both sides and I get x equals, and what do we get for inverse cosine? So it's going to be inverse cosine of 1/4, which is 0.25, 1.3181, 1.3181, 1.3181 radians. So you should be able to type in 0.7227, depending on whether how many decimal places that Hawks requests. Just read the directions and type in 1.3181. If you did it in degrees, that would be fine as well. All right. And let's go. So this problem wasn't quite finished. I was in my haste, I moved on to the next problem, and this one wasn't quite finished. So we have to talk about this a little bit. So when we go to solve triangles in the next unit, you'll see we'll do some work that will reinforce this idea. So there's a bit of a difference between if I'm talking about the inverse cosine of some number and we're talking about an inverse function versus when I take the inverse cosine of an equation, I have to consider all of the answers that could make that statement true. So it's kind of like this thing. When I talk about the square root of 64, that is equal to 8. If I talk about the square root as a function, then there are no negative values. So because it's restricted to be just this part of my reflected parabola. So when I'm talking about functions, that's the blue one is y equals x squared. When I find its inverse, I switch x and y, of course, and then solve for y, and I get y equals the square root of x. But if I plotted that, it would end up looking like this whole thing. But because this portion makes the function not a function, we eliminate it, and we only keep this portion, this upper portion, the positive part. So it can only be positive. So that's a restriction on the range of y equals the square root of x. In the same way, with the trig functions, we have those range restrictions as we did in the last unit. But just like square root, if I had an equation, so this wasn't an equation, it was just a number. If I had an equation that was x squared equals 64, and then I chose to take the square root of both sides in order to solve for x, I have to consider that there are negative values that will also make this equation true. So the answer to this equation is x equals plus or minus 8, because if I put negative 8 in the original equation, negative 8 squared is in fact equal to 64. So in the same way, when I take the inverse cosine of some number, it'll give me an angle measure. Whenever I take the inverse cosine or inverse sine or inverse tangent or inverse cosecant, secant, cotangent, the possibility that there are two angles that'll make that statement true has to be considered. The easiest, the functions were, the ratios and functions that we're most used to or familiar with are cosine and sine. So I'll show you with sine, and then we'll go back and finish this problem. So if I had the inverse sine of radical 2 over 2, that of course represents an angle, and if we walk through that, that would be something like this. The sine of some angle measure is equal to radical 2 over 2. Well, there in fact are two angle measures whose sine are equal to radical 2 over 2. That would be this guy, pi over 4. Recall its height, where its terminals, the height or y-coordinate of the point where the terminal side crosses the unit circle, or at a radius of 1, would be radical 2 over 2. But there is this guy over here as well that also has a positive radical 2 over 2 for its height. So there are two angles in this solution, pi over 4 and 3 pi over 4. So if we go back to our original question that I didn't quite finish, we have these two radian measures. I'm going to slide over here to the right. 0.7227, 0.7227, and 1.3181. Now, one of them came from, because I'm in a different place on the sheet, this guy came from the original equation being 4 cosine x minus 3 equals 0. And when we ended up solving that, we got cosine x equals 3/4, took the inverse cosine of both sides and got x equals 0.7227. Okay, so I'm going to draw this little unit circle over here, and we have to think about a couple things. So I happen to know, because of my familiarity, I don't expect you guys to see it necessarily, but when I get this angle measure, 0.7227, it comes from this 3/4. That 3/4 is talking about the length of the adjacent side, right? So that means I'm getting this angle that has a length of this side is 3/4. I happen to know that the square root of 2 over 2 is approximately equal to 0.7071, blah, 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 blah. And some of you may have seen that when you take this, use your calculator and take the sine or cosine of 45 degrees, pi over 4. And so that means this side is a little bit longer than that. So that means this thing is becoming a little bit flatter. So this moves out and this becomes longer. So this angle is a little bit less than 45 degrees. That's really not neither here nor there. So we have this reference angle right here. Cosine is positive in the first quadrant, but it's also positive in the fourth quadrant. So the other positive angle that has this same length of 3/4 is negative 0.7227 radians, which means it's this guy. It's that angle. So it could be either of those two values. So really I'm talking about my x coming from my angle measure coming from this side can either be 0.7227 or it's going to be 2 pi minus 0.7227, which is equal to 5.56045 radians. The same thing is happening with this guy over here. There are two possible angles that will give us that. And so that came from 1.3181. 1.3181. Well, where's that located? Let's go back and actually look at the angle measure. Not the angle measure. The length of the side was 1/4. So that's this guy. It's something more like that, where this side length is 1/4. And there's a reference angle that is 1.3181 radians. Well, if I draw the other triangle that also has a positive 1/4 as its length of its side and has a reference angle that's also equal to 1.3181 radians, notice how it's not pi over 2 radians, which would be like 1.557 something, blah, blah, blah. It doesn't quite make it over that way. Then that means this angle is this guy. So my two possible angles here are 1.3181 and, again, 2 pi minus that same reference angle, 1.3181 minus, which is equal to, which is 4.965085 radians. So there are four possible answers. To summarize again, x can equal 0.7227, 1.3181, 4.9651, or 5.5605. 5.5605. Those are the four angles that will make this equation true. All right?